This is our next question. Figure 6.1 shows an enlarged view of a spherical raindrop, center O. (6a) On figure 6.1, draw a ray in the air striking the raindrop at A with an angle of incidence of 49 degrees and coming from the left. So now we have to go back to figure 6.1. On figure 6.1, the normal has already been drawn. This one, this is the normal. You have to draw the incident ray right at point A. So now we have to measure the angle of incidence 49 degrees from normal, but starting from point A, not from point O. Then we will get this line. So the 59 degrees is the angle between this. This is the incident ray and this is the normal which pass through point A, not from here. Question 6b. The water in the raindrop has a refractive index of 1.33. Show by calculation that the angle of refraction at A is about 40 degrees. We will use this equation N2 over N1 equal to sin I over sin R. N2 is the refractive index of the water because the light comes from the air into the water. N1 is the refractive index of air because the first medium is the air. So this is 1.33 over 1. 1 is the refractive index of air equals to sine 59 degrees. This is the angle of incidence over sin R. Do the cross multiplication. We get 1.33 times sin R equal to sine 59 degrees. So sin R equals to sine 59 degrees over 1.33, or this equals to 0.644. So R equals to inverse of sine 0.644, which equals to 40 degrees. This is a round off number. Number 6b, double I. On figure 6.1, draw the path of the refracted ray to the point where it strikes the inner surface of the raindrop. Label this point B. Let's go back to figure 6.1. Measure the angle of 40 degrees from this side of the normal to the right. We get the 40 degrees angle from the previous calculation. Then we will get this line. This angle must be 40 degrees. The line must reach this side of the spherical raindrop. Don't forget to draw an arrow at the end of the line. Label the point where the line meets the edge of the spherical raindrop as B. Number 6C. The ray is partially reflected at B. Draw the normal and the reflected ray at B. To answer question 6C, we have to revisit figure 6.1. To draw the normal at B, first we have to draw a tangent at B. Tangent is a line which touches a circle only at one point. In this case, the point is B. This is the tangent. It touches the circle only at point B. Then we can draw the normal. The normal must form a 90 degrees angle to the tangent. This is the normal. This angle is a 90 degrees angle. After we get the normal, measure the angle between the normal and the incident ray. This one. This ray now becomes the incident ray for this part of the spherical raindrop. So, the angle between the normal and the incident ray is the angle of incidence for this part of the spherical raindrop. Then measure the angle of refraction from normal, the same size as the angle of incidence. Mark it. Draw a line from point B, passes through the mark to get this line. Don't forget to draw an arrow at the end of the line. So, this angle must be equal to this one. Question 6D. Extend the reflected ray to strike the surface of the raindrop again. At this point, it is partially refracted out of the raindrop. Draw the approximate path of this ray as it emerges into the air. Now we will draw another tangent at this point, where this line meets this side of the spherical raindrop. This is the tangent. Then draw the normal, which must form a 90 degrees angle with the tangent. This one. The ray is partially refracted and emerges at this side of the spherical raindrop. The ray comes from the water into air. Since air is less dense than water, the ray is refracted away from normal. Then we will get this line. Again, put an arrow at the end of the line. It is a must for you to always put an arrow on each path of the ray of light. This arrow shows the direction of motion of the ray of light.